Hello, I'm Josh Starmer, and welcome to Human Stories in AI with StatQuest and Lightning AI. In this series, we'll hear about the career journeys of passionate AI experts. From their humble beginnings to conquered challenges, we'll be inspired by the real-world experiences of professionals thriving in the ever-evolving AI landscape. Human Stories in AI is brought to you by Lightning AI. Code together, prototype, train, and deploy AI web apps, all from your browser with zero setup. Personally, I love Lightning AI because it makes it super easy to use and learn from the StatQuest coding tutorials. Just go to the webpage, click on the Run button, and bam! You get code that you can play with without downloading anything or installing any packages. Today, we have special guest Dr. Amy Finnegan, the Deputy Director of Data Science at IntraHealth International. Amy is a demographer and data scientist with over 10 years of experience working in global health, development, and data science in emerging economies on 4 continents. Amy is also an adjunct faculty member at Duke University's Global Health Institute. So, without further ado, Amy, can you tell us about your journey to where you are right now at IntraHealth? How did this all start?
Yeah, absolutely. I won't go back to all the way back, but I got my PhD in 2016 from Duke University, and I was in the public policy program with a concentration in, started out in political science, ended up in sociology, demography. And at the time I was doing my PhD, data science wasn't really a thing, but in the program, all my advisors told me, don't collect your own data because you'll never graduate. So we ended up having to use secondary data, merge data sets together, ask interesting questions, do quasi-experiments, run A/B tests, like all of that stuff that is now commonly part of what a data scientist does is what I was learning in grad school before data science was even a thing.
Okay.
And then within that as well, we were in a multidisciplinary program. So, everyone, your committee has to be an economist, a sociologist, and a political scientist, and they are all experts in their field, but they all approach the same question different ways.
Okay.
So I realized pretty quickly that the one thing we had in common was regression and data, right? And descriptive statistics, and the central limit theorem doesn't change based on which discipline you're in. So I really doubled down on learning methods really well, and coming from that interdisciplinary or multidisciplinary program, I felt like I could kind of address any problem using those same methods. And I also, wasn't interested in like one problem specifically. So I was probably, I don't know if you've heard this saying before, but like a mile wide and an inch deep.
Okay, sure. Yeah.
That's not allowed, really, or not encouraged in PhD program, right?
Yeah.
They want you to be the expert in one specific thing. And I was interested in so many things that I found the loophole was like being interested in methods.
Okay. Awesome.
So, yeah. And then I went to the Duke Global Health Institute, and I did a postdoc there in public health, where I actually was starting to work on projects where we were collecting data in the field. I had a really great postdoc advisor who was automating all of his scripts to collect and clean data in R. And I kind of sought him out because I really thought that those were skills that I really wanted to have. And I got this piece of advice kind of midway through my PhD program in a class called Computational Political Science, which is probably now just called data science. And they said it was taught by someone who had worked at Microsoft and then came as a developer and then was in the PhD program in political science at Duke. And he said, if you're a developer and you can program, everyone's like, great, you're expected to program. But if you're a social scientist who can program, then everyone is impressed. And they're like, this is like an additional skill that helps you stand out, and then you can solve problems that you're coming from any direction. So that's why I really focused on that. Did you have a follow-up question?
Well, I was just going to ask, and I think you may have answered this already, but so you were in this PhD and then you moved on to a postdoc. How did you choose that postdoc? Was it specifically to learn how to program, or how did you make that decision?
Yeah, it was to go from using secondary data to public health, where you're collecting your own data,
Okay.
and to really be groomed on that track of like being an NIH-supported research scientist
Okay.
and designing investigator-initiated studies.
Yeah.
And so I think the biggest compliment I've ever gotten is that I'm creative. So I've really doubled down on that, right? Like a lot of people have skills. You can be super good at something and follow all the rules, but to kind of push the envelope, you really do need to be creative.
That's exactly
to other
right.
people's chagrin at times, I'm sure. But
How did that work as a graduate student? Did that chafe you because they didn't want you to gather your own data, or?
I really loved the demographic and health survey. Like I can still remember when my advisor said, some of these questions that you're asking, you could probably answer with the demographic and health survey. And I was like, okay, well, let me check it out. And that's what I used to write all the papers in my dissertation. That's
Oh, wow.
the basis of like creating this big data for reproductive health Bass Connections group at Duke University. For about 4 years, we were working with Duke students to use big data methods on the contraceptive calendar from the demographic and health surveys.
Okay.
And then my dissertation was on using the maternal mortality module from the demographic and health surveys. So these two kind of gnarly, we can say, data sets that people don't use because they are so hard to wrangle. We saw that as like, here's a big data opportunity, and we can use these new methods that are becoming more popular to answer questions that we have about reproductive health.
Oh, I love this. So let me just make sure I get this straight, though. It sounds like, so this data set is big, complicated, hard to use, and you saw that as an opportunity.
Yeah, absolutely.
I love that. I absolutely love that. Fantastic. Okay, so we've got you as a postdoc learning R.
Yep.
Where do things go from there?
Yeah, so I finished up my postdoc, and then I had a job as a research scholar at the
Okay.
Duke Global Health Institute. And everyone will tell you there is no track. There's no like track from research scholar to like research professor, or there's no real career pathway in that job. But I had gone from a postdoc at Duke and really wanted to stay in the Triangle area, so I'm based in Durham, North Carolina. And kind of this was the next step from postdoc. It kept me at Duke University, where I had already kind of like figured things out. I felt like 7 years, I kind of understood what was expected of me as a researcher, and like I know where I'm going. I had my career development plan and my 5-year plan and all of that. And then someone I worked with, actually on big data for reproductive health, had gone to work at IntraHealth International, where I work now. And they had, at the end of the fiscal year, they would always have some, what they call budget dust, like leftover money that they could use before the end of the fiscal year, right?
I like the sound of that.
Yeah, right. And it's dust. It's not like big project material, but they would use it for kind of innovative projects that they could see if they had any legs, right? And so this guy, David Potenziani, if you're listening, David, he said that they had a bunch of data. He was an informatics guy. I think he was pushing 70 when I ran into him, and he had seen like how health informatics had unfolded in the US, and then also supporting global projects. And he was like, we've got all of this data. It's not connected, like it's siloed into different data systems, but the methods exist to link all this data together, and then the machine learning methods exist to like make sense of it, right? So that was his project proposal, and through this person I had worked with at Duke, they found me and had me as a consultant for 2 months, and it turned out to be a 2-month-long job interview. So I didn't know that they were going to hire someone at the end of this. So when the job ended, actually, this is a funny story. So the job ended, they posted this job, they sent it to me, and I was like, I don't think I'm who you're looking for. Like, I think this is like requesting too much experience and like too much of all of that. And they were like, no, just like come in for the interview. And I was like, okay, sounds good. So I came in for the interview and I met the director, and David was there and other people on the team, and the interview went really well. They followed up for the second interview and I was like, like I feel like I finally figured out what I'm doing at Duke, and this would be a big change for me. And I had just got off the waiting list for parking. It had been 2 years that I was on this waiting list. And I was like, oh, decisions. So the director of digital health at that time called me up and he was like, what do I need to do to give you this job? So
Wow.
I accidentally negotiated a pretty good deal for myself.
Oh, that's awesome. I love this technique.
Yeah, it was definitely an accident, but I kind of bumbled my way into this really great job.
I love it. I love this story. Well, I mean, to be honest, it sounds like you were given an opportunity to do this sort of consulting, and you took it. You didn't. That was the key, right? Mm-hmm. If you'd bumbled on that and been like, I don't know if I want to do this, you may have never heard from them again. But because you took that opportunity and you went with it, they fell in love with you and they were like, we have to get you. And I think there's something to be said about that, just sort of going out on a limb and just saying, oh, I think this will be fun and let's see what happens.
Yeah, and I gave up my weekend for a couple months to work on this. I couldn't use my Duke time to work on it, right? And Duke also has rules about how much consulting you can do, and so it had to fit within the rules of that. But
so you made it work.
Turned out really fun. Yeah, we made it work. And
I love it.
Yeah, and then they hired me as a senior data scientist, and then that was September 2019. Yeah, that brings me to something that I did want to say, like advice for students from reviewing a lot of student applications for our Bass Connections team, reviewing a lot of, like I've hired 3 data scientists now at IntraHealth, like reviewing cover letters and all of that. The people who say like this would be a great opportunity for me are less appealing than those people who are like, here's what I can deliver for you.
Okay.
Yeah.
Nice.
So that's a very important distinction as people are applying for jobs.
Oh, I like that. Yeah. It's basically doing the exact same thing you did in Africa. Like, here's what we can do for you. Bam.
Yep. Selling it, right? And like, here's how we mutually benefit, and this is the time it's going to take, and getting a little bit of trust, right? And building up your previous projects that you can show them the results you've had, and then they're willing to trust you for the bigger dollars, right? And that's how the Uganda consulting project happened, is that turned into bigger dollars from that same project that ended up funding a lot of my time in that first year. Because we were given the runway to just like see what can happen. Yeah. And then when we were able to solve a problem, the chief of party of that project was like, can you solve this problem too? This is the one that I really need solved.
So you said a word that I think is super important to just data science in general, which is trust, building up trust. Yeah. I can think of few things more critical to sort of the role of a data scientist than establishing and building trust, because what we do can somewhat seem like magic, like machine learning, AI, all these things. There's a lot of buzzwords in our field that I think within the field we know what we're talking about. Right. We know what these things are, but outside of the field, I feel like a lot of people are intimidated, or just like they don't know what's going on, and there's that fear of the unknown, or the fear. There's just fear, I think.
It's like every dollar we spend, the opportunity cost of spending on something that might not work, it's a risk that a lot of people aren't willing to take.
Yeah, and I think what you said was how you start, simple, and you build up trust over time, both by like completing tasks and showing utility, but I think also a lot of that has to do with clear communications in terms of like how this can benefit you.
Yep. Yeah. And also walking people through what you're doing and making it intuitive for them, because a lot of machine learning, it's an artificial intelligence. It's supposed to approximate like how the brain works, right? Yeah. Like creating that intelligence. So if you can get those really simple examples that help people grasp that intuition, then they can kind of wrap their heads around it. I really do think that's one of the gap areas in our field, is that it happened so quickly that software developers started doing data science, and in our field, strategic information and M&E people started doing data science. But the gap, I think, was teaching the technical people how to get the intuition and be able to interpret these things and then ask for it, right? Because it's only as good as the questions you're asking from it as well, and kind of thinking about their specific problems and how data science could be used to solve them. And I think upskilling some technical people would be a really good investment.
Yeah, that makes sense. Makes sense to me. So could you tell us a little bit about what you're doing at IntraHealth right now?
Yeah, so I've been here for 4 years, and one of our major projects is called READY, Rapid, Efficient, and Data-Driven Implementation, because there was a need to kind of unify all of the data coming in from our projects and how that was getting fed up to our technical experts at the global level, and then up to the executive team and up to the board. So I spent the last couple of years building that system, helping run a technical working group where it's not just data science building it. It can't just be data science. We have the technical advisors who tell us what should go in there. We've got the M&E people who tell us how to define those indicators and make sure they're measured well. And then the data science team can build those structures and data pipelines to bring them in and then display them in Power BI dashboards, which is what we do. So that's been our major project and our probably highest visibility project at the organization. One of the really cool projects we worked on in Tanzania was on voluntary medical male circumcision. So what we're seeing is that donors are asking us to circumcise more men with fewer dollars, right? So your targets are going up, your budget's either staying the same or going down, and you still need to reach your targets. So what we learned after implementing for a while is that the more men you circumcise, the fewer men there are to circumcise, right? Because you only need to do it once. And so we had older population data from the Bureau of Statistics in Tanzania that was at a higher level. So it was at the region and the district level, for example. So we had a mobile testing site, and we had kind of roving teams of health providers who could go to health sites and perform the circumcisions and then upskill providers while they were there. But what ended up happening is that these teams would go out and stand around because they didn't go to the right place. There weren't as many people as they thought there were. Even these districts and regions can be so big that even the health officers there might not know where all the people are, especially if they're populations that are moving around a lot, like pastoral communities and things like that. So this was a request from the project director of that project. It was Tohara Plus, funded by the CDC in northern Tanzania. And she said, look, I'm having this problem. We need to go more granular. So we found some data actually from Facebook, created these 1 kilometer high resolution population density maps and put them out into the wild. So we could see which had been satellite data that they had collected for free and then estimated where people were by different age groups. So we had that, which we could aggregate to the district level and then also below the district to the ward level. And so we could show where the people are, where the men are, right? And then we could use the demographic and health surveys, which I love, to estimate, if we've got this many 15 to 19-year-olds, the DHS is telling us that by age 15, X% of them are already circumcised. So let's take the number we have and reduce that by the percent we think are circumcised. And then PEPFAR, who funds these programs, it has been collecting the number of circumcisions done every quarter over the last several years. So then we could also decrement from that number the circumcisions already done, and then add in the 14-year-olds, right? And because people age 1 year at a time, that's the best thing about populations. So then we were able to overlay that with data we had on HIV prevalence, which we got from the testing and the positive test from PEPFAR. And the first time I made that map, it like popped up on my screen and it just lit up like a Christmas tree, right? It's like, here are the wards we need to go to that have higher than average HIV prevalence, and we can sort those by the number of men that we need to circumcise, so we know exactly where to go.
Wow. So yeah, just for my benefit, not being in the health business, it sounds like the end was, or the purpose was to reduce HIV rates.
Yes.
And the way you could go about it was increasing the proportion of the male populations that's been circumcised, and so that's what you guys were tackling, which makes sense. So you're trying to get it before, at an early, trying to like prevent it before it happens.
Yep, it was a prevention project for sure.
Yeah, that sounds fantastic. Can you tell us? So this data sounds really cool. How was it working with the data? Is it a huge, cumbersome data set, or is it how do you work with it?
Yeah, it wasn't too bad. Like, you need to know some of the basics of geospatial data. We were working with it in R, so you have to know the libraries that you can work with geospatial data. And then there's some really good packages for summarizing those pixels, essentially. Like, you give it the ward boundary, and then you sum up the pixels in that boundary, and that tells you how many people there are. And then you merge on the data from the demographic and health surveys or from PEPFAR that's also at the ward level. So you do have to know, like, what are those identifiers that you're going to use to link the data together. And then the issue can be that one data set says this is like a Sunshine District, and the other data set says this is Sunshine District, and like, which one is correct? And is this really the same place? So IntraHealth, plug for IntraHealth, has a tool called Gopher, which is the global open facility registry that helps you link those two lists together using some matching theory. So there are ways around it, but it was very similar to something I did for my dissertation, which was using data from Indonesia to map on deliveries and facilities and to evaluate this program called Desa Siaga, where they had this kind of rippling implementation of the program, and we wanted to see if things were better after the program.
What was the program supposed to accomplish?
Desa Siaga means alert villages, so it was supposed to have a post in the village that didn't exist before, or was kind of like repurposed to like if a disaster struck, like the big tsunami, people were designated to be the first responders. Someone would volunteer to be like, you can call me and I will be the ambulance, like if a woman has complications. So that was the Suami Siaga. That's the Alert Husbands program. So it was really about making sure that people were aware and planned for things that could go wrong.
Just like disasters in general.
Disasters, maternal complications in childbirth, probably malaria, dengue fever, COVID could activate this network of health posts to provide information.
That sounds very helpful. So it sounds like you do a lot of your work in R. Do you do all of it in R? You said you got this for doing dashboards. You guys use Power BI.
Yep, we use Power BI for our dashboards because we're a Microsoft shop, so it nests really well with all of our other tools. We use QGIS for our geospatial work because it is free.
Okay, that works. That's good for me.
R also because it is free and open source. So the people that we serve, they can't afford even the charity pricing that we get from Microsoft. So yeah, if you're looking at like, what do I spend my dollars on, licensing is not at the top of the list when you've got women dying in childbirth, right?
Yeah. Well, it makes sense. Very cool. Are there any other projects going on right now?
We're trying to get one project started because I'll go on my open source software tangent.
Sure.
So about 10 or 15 years ago, when open source software started to become developed for health information systems to replicate like what we have in the US, to make that open source so that it would support a whole country's health information system, like the facility registry, identity management, supply chain management, health worker management, electronic health records. All of those tools there are open source versions of those tools available, but they were produced or initially funded under projects that were never intended to be permanent. So you've got these pieces of software that everyone assumes because they're open source, like everyone is watching and there's a community, but what it really means is that nobody's taking responsibility, and that there's no funding for improving these core tools, unfortunately. So one project we're working on is using large language models like ChatGPT to develop our software. Right? Because it's open source, so we can just say like, ChatGPT, read our software, and then Vue.js and Node.js and OpenSearch, help us document this code, right? Or look at this bug and suggest how we can fix it, or write tests for us, right? Because our developers don't always have room or time in the budget, or things move so quickly, or priorities change, that sometimes testing falls to the wayside, but it's a really important part of software development. So we have an intern now working with us on using large language models to improve our IRIS software, which is health workforce, basically headcount planning software for governments. So,
And do you run your own version of ChatGPT, or do you just use
We're using GitHub's Copilot right now. It is like $20, $10 or $20 a month, but it's context aware, so you can have this application where you open up all of the supporting files for IRIS, and then it can read through any of them, and then it's also pulling from what it's learned from the web about software development and like Vue and Node and all of that. So we're really hoping that it can accelerate adoption of this software, that it can make them more robust with less money.
Sounds cool. Sounds very cool. Well, to wrap us up, I know you already gave us one bit of advice that you've learned along the way, but do you have anything else that you've learned that you think would be a bit of wisdom that you could share with our audience?
Yeah, one piece of wisdom. I think, realize you can't do it on your own. You need a team of people to do it. The data scientist has that kind of Venn diagram of skills, of like technical hacking skills and statistics, but you still need a full team of people to make this work. So get buy-in, create value for other people so that they will benefit from your solution. Students should be doing projects and creating portfolios so that they can show potential employers what they're capable of doing. Put everything on GitHub, document your code really well. Show teams that even at an entry level, like you can fit in and start producing value on day one.
I love it. Thank you very much, Amy. It was great speaking with you today, and have a great rest of your day.
Great, thank you.